Hi guys, we have already done concentration terms in part 1 video and we will learn today Henry's law in part 2. So let us start. By applying pressure, we can dissolve gases in liquid. So let us start Henry's law. In Henry's law, the mass of a gas dissolved in a given volume of the liquid at constant temperature is directly proportional to the pressure of gas present in equilibrium with the liquid. So, if we equal that, mass will be equal to Kp, where K is proportionality constant. Also, we can define Henry's law by the solubility of a gas in a liquid at a particular temperature is directly proportional to the pressure of the gas in the equilibrium with the liquid at that temperature. So, XA is equals to K dash PA, where XA is mole fraction of the gas in solution and PA is partial pressure of the gas and K dash is proportionality constant. The value of KH depends upon the nature of gas and nature of solvent and temperature. So if we find the value of PA, then PA will be equal to 1 upon K dash XA. Now, KH is equals to 1 upon K dash. KH is Henry's constant. So, if we put the value of 1 upon K dash is KH, then we will get PA is equals to KH XA. Now, let us talk about some results. Greater the value of KH, lower is the solubility of the gas at the same partial pressure at a particular temperature. And second result is the value of KH increases with increase of temperature, implying that the solubility decreases with increase of temperature at the same pressure. So if we increase the temperature, solubility will decrease and we will get the value of KH that will be increased. Now let us talk about the limitations. This law is only applicable when the molecules of the system are in a state of equilibrium. And the pressure should be low and the temperature should be high. That is, the gas should behave like an ideal gas. Now let's talk about some applications in the production of beverages in cold drinks. To increase the solubility of CO2 in cold drinks, soda water as well as beer and etc. The bottles are sealed under high pressure. When the bottle is opened, the partial pressure of CO2 above the solution decreases. As a result, solubility decreases and hence CO2 bubbles out. So, in the dissolution of CO2 in soft drinks. Next, let us talk about second application in the deep sea diving. In the deep sea diving, deep sea divers depend upon compressed air for their oxygen supply. According to Henry's law, solubility of gas increases with pressure. Thus, both N2 and O2 will dissolve considerably in the blood and other body fluids. So, oxygen is used up for metabolism, but due to high partial pressure and greater solubility, N2 will remain dissolved and will form bubbles when the divers When the diver come to the atmospheric pressure, these bubbles affect nerve impulse and give rise to a decrease called bends or decompression sickness. Let us talk about the third application in the function of lungs. When air enters the lungs, partial pressure of oxygen is high. Thus, oxygen combines with hemoglobin to form oxyhemoglobin, and partial pressure of O2 is low in tissue. Hence, O2 is released from oxyhemoglobin, which is utilized in the function of cells. Fourth, next application is people living at high altitudes or mountain climbers. At high altitudes, we know the partial pressure of oxygen is less. As a result, there is low concentration of oxygen in blood at high altitudes. Consequently, the people feel weak and unable to think properly. The disease is called anoxia. So, I hope you got what I have taught. Thank you, students.